This integral is not really easy, quite complicated. Now when I see denominator as something square, there's something square in a denominator, and this is dx, right? I'm thinking of this, this. I'm thinking of this. So if I can change this one to that, then I can use by parts, So how change this one to that one? So I'm gonna consider this, right? 2x squared plus 1. This one is equal to 2x squared plus 1 square, and I need 4x, right? Then dx. Yeah, that's a chain rule, right? And in order to have this, I must have that. See, I must have this, then I have this. But look at denominator, look at numerator. I don't have a 4x, but I can create. At the same time that I maintain an equal sign. Okay, this one is equal to 2 x squared plus 1 square, right? And I have a e to negative x squared dx. That is what I have. But I want this. So I must have created this one. Same time that I divide by x and divide by 1/4, Now then they are equal, right? They're equal. The same time that I have what I want. Okay. Yeah. Then this equal to integral e to the negative x squared. That is this here. This one's there. This becomes the derivative of 2x squared plus 1. Negative, huh? I have negative also. So I have a negative. Yeah, now it's equal. Yeah. Well, so-called techniques just change the integral function, but at the same time to maintain the equal sign. Of course, I change it to what I want. Here I can use by parts. So I can use by parts, right? So this one equal to negative 1/4. This is u, this is v, right? This is x times 2x squared plus 1 e to the negative x squared. That be okay. Minus the v here become plus, right? V is this, du is. Now v is this, 2x squared plus 1, and x du is this derivative, right, which is x squared, and this square times this one is a negative 2x squared e to the negative x squared minus this derivative times this one is a negative e to the negative square dx. So this one is equal to minus 1/4 e to the negative x squared x2 x squared plus 1. The main thing is this. Main thing is the next integral. Okay. The next integral is that this is x squared, right? Yeah. And this cancel with that one is a negative. Leave negative outside. And this is e to the negative x squared. Because 2x plus 1 cancel with that one. Yeah, that is still problem. This is a still problem. I mean, we didn't solve we didn't really solve the question, the problem yet. Now, this is my v. This is my v. This is my v. This is my du. Now, du has x squared here. If I have x squared there, if I have x squared there, then the problem is solved. Do you understand? If I have a, let me write something. That's the very key of the question. I have this d 2x squared plus 1. This is not good because I have x squared there. Now, if I have this, let me change this. If v is not this, if v is this, if v is this, then the problem is solved because there's x squared. Okay, x squared cancel out because the problem is solved. Now, how can I change this one to this? That is the key. Which means this is what I have. This is what I want. I want to change this one to that one, but maintain the equal sign. Okay, let me do this step by step. This is the very, very interesting. Now I have to maintain the equal sign, right? This could be 1 minus 2x. Are they equal? To negative outside. They're equal, right? Now they're equal. And this one equal to negative d 2x squared plus 1. This is 2x plus 1 minus 1, right? It's 2x squared, isn't it? This is not what I want. I have x squared, no 2. No 2. So, that's easy, right? Take 2 outside. So this one is negative 2 d x squared 2x squared plus 1. That is what I want. I have this, at the same time the equal sign. Negative 2 I can take out. Well, do you, well, I hope you follow. Then this one is equal to, then this, I have to reconsider. I change this one to this. The problem is solved. Okay, so this is I, right? I is equal to 1/4 integral x e to negative x squared d 2x squared plus 1. Well, I forget the boundary. Okay, this one to from 0 to infinity. Okay. Now that is what I have had before. Okay. Now I have a solution that says I must change this one into this. Then the problem is solved. Okay. So I'll change this one into minus, there's a room for this one, minus 1/4 from 0 to infinity at this time, and not forget it, e to the negative x square x. This one, I'll write this one, negative 2 d x square 2x squared plus 1. Yeah, then the problem is solved. This becomes a 1/8, right? Not 1/8, but this is equal to 1/2. Sorry, this is 1/2. Now can use it by parts. U dv, right? U dv. U is this, v is that. So it becomes e to the negative x square, x cancel out, 2x squared plus 1 from 0 to infinity, minus integral v du. V is this, 2x squared plus 1 x squared. Du is what I've done before, okay? That is this, x squared minus 2x squared e to the minus x squared minus e to the minus x squared dx. Yeah. That one is easy. We can use L'Hopital's rule also, it's equal to 0. So this is gone. And equal to 1/2. The negative cancel this negative. This is cancel out. This is cancel out. Should end up with e to the negative x squared dx from 0 to infinity. Yeah. The other one is easy. This is the Gauss integral, right? 1 plus half square root pi. So at the end there's a 4 square root pi. That is the very answer. Okay, good. Now I just let's repeat again, saying this. I want to change this one into this. That is the main part. That is the very, very good techniques if you can learn from it. Thank you for your watching.